is an example of the period of a simple pendulum. And this is actually an example from the multiple choice problem set on AP Classroom. So we have a simple pendulum consists of a 1 kilogram brass bob on a string about 1 meter long and has a period of 2 seconds. The pendulum would have a period of 1 second if we look at the equation for a period of a simple pendulum, that's just going to be 2 pi times the square root of the length of the string divided by the acceleration of gravity. So we can see here that the only things that are going to affect the period of a pendulum are the length of the string and the acceleration of gravity of whatever planet we're on. So because of that information, we can already cross out some options here in our multiple choice. So we can see that A and B are both feasible options because they're talking about replacing the string with one of a different length. So if we change the length, it is going to change the period. So we want to leave those there. It's going to be one of those answers probably. We can see that C and D are both talking about changing the mass of the pendulum bob. And we can see here that there's no mass term in our period equation. So because there's no mass term in our period equation, that means that mass does not affect the period of the pendulum. So we can cross out C and D because if we change the mass, the period's not going to change. And then also for E, if we change the amplitude of motion, the period also will not change because it's not in the equation. So we can cross out E as well. So it has to be either A or B because the length of the string is the only thing that's going to change the period of the pendulum. Now, the other thing here is that we can probably do this intuitively because we can see that if the period is decreasing, so the first period is 2 seconds and the second period is 1 second, if the period is decreasing, we can see that since the length is on the numerator here, then the length also has to decrease. So do you see how B, it says the string were replaced by one 2 meters long? There we have an increase in length. So if we did have an increase in length, we would have to increase our period as well. So the answer has to be A because if the period decreases, the length also has to decrease. So it has to be option A. Now let's do this. Let's prove it though. And the first thing we have to do if we're going to prove this answer A is we have to see if our G is for the Earth because it doesn't say that we're on the Earth. So we can't really assume that we are on the Earth. We could be on some other planet testing the period of the pendulum and what affects it. So let's find G first. So we have a simple pendulum consists of a 1 kilogram brass bob on a string about 1 meter long and has a period of 2 seconds. So our period of 2 seconds is equal to 2 pi times the square root of 1 meter divided by G. Solving for G here, I get 2 divided by 2 times pi. I'm going to square that. And then we get 0.10132 equals 1 over G. So 1 divided by our answer. And our acceleration of gravity, G, is equal to 9.87 meters per second squared. So we are on Earth, but it was helpful to check. So now we can use this acceleration of gravity in our equation once more, but now use our new period to find our new length. So new period is 1 second. That's going to be equal to 2 pi times the square root of the length over 9.87 meters per second squared. So 1 divided by 2 times pi. I'm going to square that and then multiply that by 9.87. And so here for length, I end up getting 0.25 meters for my answer. So it is letter A. I did prove it mathematically, but you can also do this conceptually as well, just by looking at that equation and knowing what variables are in there and how when you change the period, when you change the length, how the period is changing. If length increases, period increases. If length decreases, period decreases as well.